These are the notes to go with our 18.0A and 18.0B assignment. Our textbook doesn't have a section 18.0, but we thought it would be good to review the special right triangles before we go into the rest of the new stuff we're doing with this. The special right triangles, there's two kinds of special right triangles. One is 30, 60, 90 triangle. One is 45, 45, 90 triangle. We're looking at the 45, 45, 90 triangle first here. 45, 45, 90 triangle has two equal angles, which means it also has two equal sides. Those equal sides are congruent, same size, and they are always the short side. There are two short sides because they're the same. And then we have our hypotenuse, which is, of course, our longest side, and it's always opposite from the right angle. Opposite from the right angle is the longest side. So the pattern, I would say, is n, and root 2. Let me look down here and talk about ways to identify, because they don't always tell you the 90 and the 45 and the 45. If we have, let's look at this middle one first. Here's a triangle that has a 45 and a 45 and unlabeled side. We really can't just assume things are right angles because they look like it. So if I think about what we did in the 17.1 assignment, I said, take the 180 degrees for a whole triangle, subtract the parts you know, and you get the number of degrees for the third angle, which means this has to be 45 and 45 and 90. If I look at this one, I'm seeing a 45 and a 90, but I'm not seeing another 45. So I could say, what if I didn't know that 45, but I did know the 90? So if I put in a 90 right here, I get 45. So then I would know this is a 45 degree angle. I know I wrote that pretty small, but we know what it is. Let's see, what if I look at this one? It tells me 90, but it doesn't tell me the other angles. But I do know from last year that if you have two equal sides, you have two equal angles. And so if I took this same little equation I had up here, and I said 180 minus 90, I'd have 90 degrees left, and I need to take that 90 and split it into two equal angles, and I would find out those are 45 degrees here. Again, I'm going to write it kind of small, but just so we can remember it's there. Below that, I have this picture. This time, they told me right angle and two equal angles. So by the same thing that I learned up above, I know that if I've got 90 for one of those angles, I have 90 left over to split between the two angles. 45s and 45 again. 45 and 45. And those are definitely degrees, even though sometimes when they're squeezed inside, we don't always write the degrees. The fifth triangle in this space shows me equal angles, equal sides, but it doesn't tell me about this top angle. You can't just assume it's 90 because it looks like it's 90. What if it was 100? If it was 100, I'd have 80 left over, which I could split into 40 and 40. We don't know for sure. It could be 90.001. And then the other angles would be just slightly above 40, just slightly below 45. Let's find a 45, 45, 90 triangle down here. This first one is a 45, 45, 90 triangle. I know that because it has a right angle and two equal sides. So I'm going to say the hypotenuse. Let's look at the short side first. I always want to know what the short side is. These two are the same size. They're both the short side. And the hypotenuse is the short side times root 2. I know that's the hypotenuse because it's opposite from my right angle. But I need to know the missing sides. And I know the hypotenuse, I need the other two sides. I've just made myself an equation that says 10 root 2 is equal to n root 2. And I want to get my n by itself. So I'm dividing by root 2, dividing by root 2, so that those root 2's cancel, giving me just n, and those root 2's cancel, giving me 10. That means my matching short legs are both 10. I showed a little work for that, but the root 2 was already on the side that should have a root 2, so I'm thinking that a lot of us don't really need to show any work for that problem. What I just said I put in writing in case you want to write it down. Do I see another 45, 45, 90 triangle? One that looks like the sides are the same, although we can't always trust that. We come to the very last one in my list here. I look at this one. I see a 45 and a 45. If I took 180 minus 45 minus 45, I'd have 90 degrees for the other one. You had to write that down when we're doing Mod 17. But for this chapter, I just want you to start recognizing those. So I don't care if that actually is written on your paper or not. I have a 45, 45, 90 triangle. Drawing my little 90 since I know now. I have two matching sides. Those are the two legs, not the hypotenuse, but the two legs that meet to form my right angle. And I need to know what those are before I'm done here. The problem here is that the side that should have a right angle, should have a root 2 because it's opposite from the right angle, doesn't have that. I'm going to make this equal to n root 2. I'm supposed to have a root 2 on that side, and I don't. So I want to get the n by itself. So again, I'm going to divide by root 2. This time, it's not so easy, so I expect to see some work for it. So now I have 10 over root 2 equals n. And in Mod 18, this is Mod 18. On Mod 17, 17.1b, and 17.2, if you chose to do 17.2, we may have done some problems where we had to rationalize the denominator. We're not allowed to have a radical on the bottom of the fraction. So in order to get rid of the radical that's on the bottom of the fraction, we multiply by whatever radical's down there on the top and on the bottom. Root 2 over root 2 is basically 1. So multiplying by 1 is going to change the way it looks, but it's not going to change the value. So now I have n equals root 2 times 10, let's call that 10 root 2, over root 2 times root 2, which is root 4, but that's just plain 2. Basically multiplying the bottom by the radical that's already on the bottom. It doesn't get rid of the bottom, it just reduces the bottom down to a whole number. And then let's look to see 10 root 2 over 2. Since 2 and 10 are both outside of the radical, I can reduce them. 2 goes in there once, 2 goes in there 5 times. I now have 5 root 2 equals my n side. That's actually both of these sides up here, isn't it? 5 square root 2 and 5 square root 2. This one, I expect to see some work. The other two examples, the two middle ones here, are definitely not 45, 45, 90 triangles. They don't look like they have two equal sides. They definitely don't have 45-degree angles because one has a 60 and one has a 30. So we're going to come back to the top and we're going to look at our 30, 60, 90 pattern. In our 30, 60, 90 pattern, we let the shortest leg is still the end. We always start with the shortest leg. That's how they build it. And then we have the hypotenuse, which is 2 times and as long as that. And remember, hypotenuse is the longest. Hypotenuse is always opposite from our right angle. And then we have the medium-sized angle, which is our 60, which is also opposite from our medium-sized leg. If you use your calculator and find the square root of 3, you'll find that the square root of 3 is about 1.7. So we're talking about 1n, 1.7n, and 2n. Medium-sized angle opposite medium-sized side. Medium-sized, longest side opposite biggest angle. So I'm going to look at the examples we have down here. And we're going to use the same process we used before to say, if I had 180, and I took away 90, and I took away 60, I'd end up with 30. I know this is 30 degrees. Same process. If I took away 30 and 60, I'd have 90 degrees. Over here, if I took away the 30 and the 90, I'd have 60 degrees. But one that's not as obvious to a lot of us is these last two examples. If you have one side, if you have a right triangle, and the hypotenuse is twice as long as the short leg, it's got to be a 30, 60, 90. And the short leg has 30 degrees opposite from it and 60 degrees here. Also, if one angle is twice as big as the other, the two acute angles, then we have to have 30 here and 60 here. If you looked at 180 is equal to the 90 plus the A plus the 2A, we could solve that out and we'd find out that A is 30. These two middle examples are like that. The first one has a 60-degree angle shown and a 90-degree angle. So I know that the last one has to be a 30-degree angle. I also know that 30 degrees is my smallest angle, and opposite from my smallest angle should be my smallest side, my basic end. My hypotenuse is always 2 times the shortest side, and my medium-sized side, which is my long leg, is always short leg root 3. I don't know what n is yet, so I have to use the only side I know to figure out what n is. I need the n by itself, so I'm dividing by root 3 on both sides. That gives me 5 for my n side. You might have been able to just see that based on if 5 root 3 equals n root 3, it's kind of obvious that the n has to be a 5. I'll put the 5 over here. And then I need this side, and what is 2 times 5? 2 times 5 is 10. That is simple enough. I don't really think you need to write it down. So again, I'm going to say, this is one where I don't think we need to show work because the radical's already on the proper side to make it fit this pattern. Put that in writing in case you need to write it down. Okay, the next one's also a 30, 60, 90. We have a 90, we have a 30. If you have a 90 and a 30, it's the only way it can add up to 180 is if the last one is 60 degrees. I look for the shortest side, and the shortest side would be opposite from the tiniest angle. So opposite from 30 is my basic side. Opposite from 60 is my n root 3 side. And my hypotenuse is my 2n side. Now, I don't know n. I need to know n. So I'm going to make myself an equation over here, give myself a little more space, and say the 2n side is 14 root 2. I don't need to know the 2n side because I know that. I need to know the n side. So I'll say if I want to get the n by itself, divide by 2. That gives me n equals, I can't reduce the 2 with the root 2 because one's inside of a radical and one's not inside of a radical. But I can reduce 2 goes in there once and 2 goes in there 7 times and say the short side is 7 root 2. I'm going to come down here, write it on my picture, 7 root 2. Last thing I need is the long leg. This one found the short leg for me. And I need the long leg. I already had the hypotenuse. I need long leg. So the long leg is always going to be my n root 3. But in this case, I already know that the n is 7 root 2, and I have to take that and multiply it by root 3. So now I have my long leg is 7 root 6. If it's possible to split up a radical, you should split it. But if I try to split up the root 6, I get 2, I get 3, I get no pairs, so it didn't do me any good. So now I have 7 root 6 for this long leg. Let's write it over here. Did I have to show some work for that one? Even if you think you can do it without work, I want to see some work for that one. Again, put all that in writing. You don't have to write down every time. But just so you have it clear, when do I have to show work, when do I not have to show work? If you're not sure, figure out a way to show me some work. The next page has more examples, and I've taken the basic pattern off the top of the page. But I think we can remember it. If we need to flip back to it, we'll do that. The first example has 2 equal sides, and 2 equal sides automatically means 2 equal angles, which means we have a 45, 45, 90 triangle. When I have a 45, 45, 90 triangle, I can say the 2 legs, the short parts, the parts that meet at my right angle here, are going to be my n. And my hypotenuse is always the short side times root 2. We've got a 45, 45, 90 triangle. Now this one's pretty basic because even though it looks like a decimal, it is a decimal. Even though it's a decimal, it has not a whole number on the side. You expect to see a whole number, but at least there's no radical there. So this side over here that we're trying to find is the short side times root 2. That's all I need to know. I don't need to change that into a decimal. If you choose to watch Miss Franken's video on this, I think she changed that one to a decimal because she said if it starts with a decimal, we'll give a decimal answer. But this section didn't want you to change them to decimal form. So I have 5.7 root 2. And I also have this side over here is just 5.7. When you look at this in your handbook, every single side is already labeled as a letter, so it's easier to write down what you're doing. The next example, okay, let's just write no work required. Because again, the side that was not supposed to have a radical, it didn't have a radical, even though it wasn't a whole number this time. This one has one angle twice as big as the other. And I'll show you how we could prove that it's a 45-45, how we could prove it's a 30-60-90. But you don't have to, because I'm going to erase the work afterwards. I know that 90 plus A plus 2A, again, this is not required work, equals 180 degrees. So now I have 90 plus 3A equals 180 degrees. I want the A's by itself, so I'll subtract 90. 3A equals 90. Divide by 3, divide by 3. A equals 30. That tells me that this is a 30-degree angle, and this is 2 times 30, 60-degree angle. That just proves what I said up above, previous slide here, but it is not something you need to write down. We're going to work on how do we find the sides. This is a 30-60-90. The side opposite from the smallest angle is your shortest side, your N. Your hypotenuse is a 2N, and your long leg, which is your medium-sized side, is an N root 3. Okay, I don't know N yet, but I just made myself a little formula I can solve that says 2N equals 14 root 2. Divide by 2 on both sides to give me N equals 7 root 2. Again, remember that you're not allowed to reduce a root 2 with a plain 2. You have to do the outside number with an outside number. So this side, 7 root 2. And then the long leg is the N root 3. But in this case, I know my N is 7 root 2, but I have to multiply it by root 3. This is 7 root 6. Going back to the previous slide for a second. Isn't this the exact answers that we got right here? In this one, they gave me 30 and a 90. In this one, they gave me A and 2A, but I still got down to the same answers. I had to show some work, unless I happened to notice it was the same problem as the one before. So I'm still going to write show work. Now we have two problems where they're just giving you sides, and they're asking you, does this form a 45-45-90 triangle? Does this form a 30-60-90 triangle? And I think that the problems of this type are actually not going to show up until we get to the 18.0B assignment. So I'm going to do them last, so that if you want to wait and watch them tomorrow, you can do that. Here we're going to find the perimeter and the area of a square that has a diagonal of 18 inches. Now, all the ones we did before, they didn't have inches, feet, meters, miles, but when they give it to us, we have to think about it in our answer. And I hope that you know that a square has right angles in all four corners. And when it's a perfect square, the diagonals split that 90 in half to make 45 and 45. Same thing on this side. The diagonal splits the 90 in half. So we have 45 and we have 45. So I'm going to be looking at one of those triangles. Okay, I'm just going to look at the red triangle. And I'm going to say my hypotenuse is 18. I need to label some sides here. I have the two that meet at the right angle are my two short sides. And this one's my hypotenuse, and the hypotenuse of a 45, 45, 90 should be the short side times root 2. I'm going to take that information that I know, and I'm going to make myself an equation that says n root 2 equals 18. I want my n by itself, so I'll divide by root 2, divide by root 2, so that now I have n equals 18 over root 2. I need to rationalize. I'm not going to keep any radicals on the bottom of the fraction. If there's a root 2 on the bottom, I'm going to multiply the top and the bottom both by root 2. This means that I now have n equals 18 square root 2 over root 2 times root 2, root 4. But root 2 times root 2 always just turns into plain 2. And then I have some outside numbers that can reduce. 2 goes in here once, 2 goes in here 9 times. So I now have n equals 9 root 2. That will be the sides of my square. Basically, I say if you're working with 45, 45, 90 triangle, or you're working with a 30, 60, 90 triangle, mostly I just want to figure out the end side first before I go on and go back and say, what do they want me to find? Perimeter. The perimeter of any shape means add up all the sides. And in this case, the perimeter is 9 root 2 plus 9 root 2 plus 9 root 2 plus 9 root 2. Now, just like if you were adding x's, if you had 9x plus 9x plus 9x plus 9x, you'd add all the front 9s and leave the root 2 alone. But for some of us, an easier way to think about this is 4 times 9 root 2. Then it's easier for us to see 4 times 9, 36 root 2. This was originally measured in inches, so the perimeter is inches. I also need to find the area. And the area of any rectangle is the length times the width, or the base times the height. In this case, my area is a base of 9 root 2 times the height of another 9 root 2. Or some people would say in a square, it's just the side square. But basically, I'm going to do 9 times 9 is 81. Root 2 times root 2 is root 4, which is plain 2. So I have 162. And it was measured in inches, but because this is area, I need to call that 162 square inches. Okay, that gave us both perimeter and area. The next shape just asked me for the area of an equilateral triangle with a side of x. I hope that you remember equilateral means equal sides, but when it's a triangle, equal sides also means equal angles. So I'm going to just take a second here and think about 180 degrees for all three angles divided into 3 equal parts tells me that I have 60 degrees for each angle. 60 degrees for this base angle. 60 degrees for this base angle. And because it's equilateral, the altitude, the height, the one that makes a right angle down here, splits the top equally into 30 and 30. 60 divided by 2 is 30. They told me that it has a side of x, so I'm going to put x here, x here. This whole piece here is x, but I'm going to call each half of this x over 2, x over 2, because it will make it easier for me to work with this thing. I need to find the area of a triangle, and the formula for the area of a triangle is 1/2 times the base times the height. You could do base times height divided by 2, but when I have fractions already mixed in there, I'm going to go with the fraction form. So my area equals 1/2 times the base, and I would say that base is x, times the height, I'm going to call it x over 1, times the height, which I don't know the height, so I have to come over here and figure this out. I'm going to look at half of this equilateral triangle. So I have a nice 30, 60, 90 triangle. If I'm looking at a 30, 60, 90 triangle, I get to call this short leg n, and the hypotenuse my 2n, and the long leg opposite from 60 becomes my n root 3. So in this case, what I really need to know is not the hypotenuse, because I already know the hypotenuse is x, that doesn't help me any. I need to find the height, and the height is my n root 3. So if my height is my n root 3 side, and I know that my short leg is x over 2, then I would have to say my height is x root 3 over 2. I'm going to put that up here, x root 3 over 2. So that I can say the area of this equilateral triangle is the top is 1 times x times root 3. So x squared root 3. And the bottom is 2 times 1 times 2, so it's just 4. And they didn't tell me inches, feet, meters, miles. And they didn't even actually give me a number for x. Now the good thing about that, even though it's a little weird that it has no number answer at the end, is that the next time that somebody asks you to find the area of an equilateral triangle, you don't have to go through all that work we just went through. If you can just use this formula, if somebody told you the side was 56, you could say area equals 56 squared root 3 over 4. Ran off the edge there, didn't I? And it doesn't matter what they told you. You could take whatever it is, put it into that spot, and you could work it out without so much work here. Okay, that's the end of the notes. I'm going to make a new video. Nope, that was going to be the end of the notes. And then I thought, might as well finish off these other two problems, even though they don't show up, I think, until the 18.0b assignment. It says, do root 6, and 2 root 3 form a 45, 45, 90 triangle. First thing I look for in a 45, 45, 90 triangle, if all I know is the sides, is I need to say, are there two sides that are the same? There are two sides that are the same. If it's going to be a 45, 45, 90 triangle, the inside would have to be the sides that are the same. And the other side is my n root 3 side. And it has to be whatever I got for n times another root 3. The question is that this? Root 3 times root 6 becomes root 18. And I'm going to use a factor tree to split up my 18 and see if I can simplify it down to 2 root 3. Well, I'm going to start with 3 times 6 because that's where it came from. And I'm going to split that to 2 times 3. Might have been better if I put those 3's side by side, but I can see a pair of 3's gives me an outside 3 and a leftover 2 that didn't pair up. 3 root 2. Okay, that was a pause because I found a mistake. I'm not looking at a 30, 60, 90 triangle. I'm looking at a 45, 45, 90 triangle, which means the hypotenuse should be n root 2. So I need to think about root 6 times root 2, which means I'm splitting that root 12. Taking 12, making myself a factor tree. 2 times 6, 2 times 3, pair of 2's, turns this into a 2 outside, root 3 inside. And yes, that matches up with the third side there. So I have my n, and n root 2. So the answer to this one is yes. I think that in your homework it doesn't ask it as a yes-no question. It asks you, is it a 30, 60, 90? Is it a 45, 45, 90? Or is it neither? First thing I'm looking for if I want to know if it's a 45, 45, 90 is 2 matching sides. If I don't have 2 matching sides, I move on and check if it's a 30, 60, 90. The next example here gives me 5, 10, and 10 root 3. Even if they asked me 30, 60, 90, 45, 45, 90, or neither, I would say it's not 45, 45, 90 because they don't have 2 matching sides. Instead, I'm going to go with, if it's a 30, 60, 90, then the n side is the shortest side. And I would need also a n root 3 side, and I would have a 2n side. Now it does look like there is a 2n side. This one looks like it's 2 times 5, so I could call that my 2n side. And then my other side would have to be the n root 3. Unfortunately, the other side they gave me isn't root 3 times the short side, it's root 3 times the long side. And since it doesn't fit that pattern, I have to say no to that question. You'll see some of those in the assignment, but they're asking 30, 60, 90, 45, 45, 90, or neither. So first check, if you don't have 2 equal sides, not 45, 45, 90. If you do have 2 equal sides, then you need to check and see if the third side fits with root 2 times the short side. If you have 3 different sides, choose the shortest side to be your n. Check and see if there's a 2 times that, because if there's not a 2 times that, throw it out. Don't waste your time on thinking about the radical one. Okay, that's the end of those notes. I'm going to stop and do some problems from the assignment in a separate video.